Here's number 10. From section 4.1. This is when we first learned about antiderivatives and used initial conditions to find the C value. And then looks like in this, we're going to find the D of T and use that D of T to estimate the credit market debt in 2020. All right, since 2013, the annual rate of change, look at the wording, rate of change. So we're going to be given a derivative function. In the national consumer revolving credit card debt can be modeled by the function d prime of t equals 12.922t plus 11.474, where d prime of t is in billions of dollars per year, and t is the number of years since January 2013. Source based on data from federalreserve.gov release. Okay, so what do they want? Part A, find the credit market debt, d of t. So here's what they gave you. They gave you d prime of t. Hey, here's the rate of change function. And they're asking you to find, can you use that to find d of t? Of course we do. We do know how to do that. What we're going to do is we're going to find the antiderivative of d prime of t. And that is going to be our d of t. Okay, let's use that. And pay attention to this critical value. They said at t equals 0. And what does it mean t equals 0? In 2013, the credit market debt was $848.8 billion of dollars. Okay, so let's go ahead and use that initial condition that I highlighted in yellow. But first, let's take the antiderivative. So what is the d prime of t? 12.922t plus 11.474, and then don't forget little notations like dt over there. Let's go ahead and find the antiderivative. So 12.922t raised to the second power, and then divide by the new power of 2 plus 11.474t to the first power and divide that by the new power of 1. That's just going to be that. Plus what variable? Plus c for this unknown constant of integration, right? But we're about to find that. Now this is, well, I don't want to call it d of t yet because I want to find what t is. Let me go ahead and see if I can just divide 12.922 divided by 2 is 6.461 t squared plus 11.474 t plus c. And now we're ready to plug in the initial condition that we were given. The initial condition is that when t is equal to 0, 610 squared plus 11.474 times 0 plus c. The credit market debt was how much? $848.8 billion of dollars. So solving for c, notice these will just go straight to 0. So it's easy for us. C is simply 848.8. We found the d of t function. The function is going to be 6.461 t squared plus 11.474 t plus the constant 848.8. That is the answer for A. We found the credit market debt d of t function using finding the antiderivative and using the initial condition. Now, part B, they want you to estimate the credit card market debt in 2020. Find T for year 2020. T equals 2020 minus, what was our base year? I forgot. Since 2013, right? 2013. 13. So that's what? 7 years. So you're going to plug in 7 into your d of t. 6.461 times 7 squared plus 11 times 11.474 times 7 plus 848.8. That's going to be approximately, what's that? That's going to be approximately, let me type this in my calculator on my cell phone. This isn't going to be too complicated. But we'll talk about how to write our answer. Because I remember the measure was, so what was the unit? Like in billions of dollars. Okay. So let me go ahead and just figure out what that is by evaluating. You do the same thing. Plus 11.474 times 7. Last one is plus 848.8. All right, guys, I typed it in, and what I got is 1245.7, 1245.707. And you know what? Let me just go ahead and say this was in what? Billions of dollars, no billions. So that's probably good. Yeah, that's good. You just gotta remember this is billions of dollars. If I want you to round it to the nearest million or something like that, I don't think I'll do that. But just double checking, was that something that it's 1245.707? 1245.71 billion. So yeah, that's fine. Just didn't really give you a strict rounding rule here. But that's how you would do number 10. And that is all I got. I'll go ahead and insert this screenshot, this picture there, along with the video. I didn't get any emails about any other problems, but just got an email about how long is our final exam. That kind of scared me because this has been going on for a while, guys. You're gonna have exactly 10 problems on your final exam, similar to the ones that you and I went over this week. It's gonna be sent out at 6 p.m. today, so you have. If you want to work all night, that's okay. But I just want it submitted by 9:40 a.m. No later, 9:40 a.m.